Hey everyone, let's try another problem. This is LeetCode easy problem. This is to find the pivot integer. Given a positive integer and find the pivot integer x such that the sum of all elements between 1 and x inclusively, means this 1 and x should include, equals to the sum of all elements between and x and inclusively, means in this part x is also include, and from x to n this x should also be included, right? So we need to find that integer x where from 1 to x and x to n both summation of all the elements are equal. If there don't exist any integer, then we will return -1. So see, if we see the first example, then here n is equals to 8. So the pivot integer should be x, because from 1 to 6 and from 6 to 8 both summation of all elements should be 21. So in that case, the first approach which should also come to your mind, that we will take a uh, two variable from okay, we will take a two variable or two prefix sum, uh, like this, two prefix array and one prefix array and suffix array, and storing from one, because the constants are only 1000, so we can store it in two arrays. So take a prefix from starting to end and a suffix from ending to start, and for every index we will see that at which point the prefix sum and the suffix sum will be equal. Like in this case, from 1 2 3 4 5 6 7 and 8, if we take prefix sum, let's leave in space. If we take a prefix sum, then it will equals to 1 3 6 10 15 21 28 and go on, right? And if we take the suffix sum, then from 8 part, this is 8, then this becomes 15, right? Now it becomes 21, it becomes 21, now it becomes 26, and like that, right? Right. So if for every index we will see that which prefix index and prefix suffix index should the summation the value is equal. Like in this case, this 6 value, if we see the sixth index, this 21 is equal, so the answer will be the sixth in case of n is equals to 8, right? So but it will this time complexity will be O of n, but its space complexity will be O of 2n, right? Which is not good in this case. So we can we see this, can we further optimize it, right? So if we see, uh, we don't need this both arrays, right? If we take only prefix, and instead of taking suffix, if I take only a variable, let's instead of this suffix, if we take a variable, let's some value, let's take a variable sum for storing suffix, right? So and now I'm start iterating from last point. So in suffix, first it becomes 8, then it becomes 15, now it becomes 21. So this prefix index at 6, prefix summation at index 6 and this 21 becomes equal. So our answer must be the pivot value is 6, right? So we had reduced this space complexity from O of 2n to O of n. So now if we think to optimize it further, so can we think of any mathematical approach for this? This is the simple for that everyone can think of. So if we try to reduce some mathematical computation uh, with this, so what I can see is the summation of the x from natural numbers from 1 to x is x into x plus 1 by 2, right? I think this you will know exactly, right? Summation from 1 to x, right? So this is equals to x into x plus 1 by 2, right? And for n is it becomes n into n plus 1 by 2, right? So we need to equalize both of these. So what I can do is I will simply deduce a mathematical expression that this should be equals to x into x plus 1 by 2, right? That, like, if we see the first example, that 1 to 6 should be equals to 6 to 8, right? So 1 to 6 value is x. I mean, x can be any variable, right? X, suppose let's x is the answer, let's x is an answer, right? X be an pivot value, right? So x can be in any answer, so this summation should equals to n summation minus this summation, but this 6 included in both of this summation, right? So I need to include this x in this, right? This looks good. So if we simplify this, so we will see this x can be moved to this left hand side. So now it becomes x into x plus 1 by 2, right? So if we do that, so here it becomes n plus 1 by 2 and plus x. Now if we further deduce, then it becomes x squared plus x. Sorry, this should not be less than 2, because both they are 2 times, so it will get already detected. Now this x, now this is n plus 1 by 2, right? So this expression x, so this x and this left hand side x, this both will be minus, cancel itself. Now what I can see is, I can see that this becomes x square. It means if the summation of n, right, from 1 to 8 is a squared value, is a perfect square value, then only the answer will be exist, otherwise we will return minus 1, right? In case of n is equals to 8, summation is equals to 8 into 9 by 2, that is equals to 36, whose perfect square is 6, which is perfect square, right? In this case, if we take n is equals to 4, which is given here, so that will equals to 10, which is not perfect square, so I will return minus 1, right? So now we, from here to here, we have done a pre-computation thing, like, right? So we will see this x square things. Now I think you know how to check the perfect square of any number, right? So this is an 1000 only, so its perfect square can be 10 to the power 6, right? So yeah, I think that will be enough to check. So if we take a bit manipulation approach, so if a number is a perfect square, so for perfect square, what we will check that from, so for that I can see is I can store the summation n into n plus 1 by 2, which is equals to summation. So for calculating the perfect square, there are many approaches. You can take any of them. First one is I can simply see that I can simply store square root of the summation, and for that I can see that, also you can see that if this x into x is equals to this summation value, so if it is equal, then I will return simply this, otherwise it is not a perfect square, right? So its time complexity will be O of square root n, right? And the space complexity will be O of 1, right? So but O of square root n, because we need to calculate this time complexity will be O of square root n, and the space will be O of n, right? But we can also reduce it by using binary search. If we use binary search for calculating the perfect square for summation, which will further reduce it to O of log n. O of this the summation O of login, right. So you can see this O of binary search for calculating the perfect square, right. Let's submit it. Right, so let's submit. Yeah, this 100% passed. This is 100% passed. You can also use O of login. Binary search means for that you can simply take a variable from L is equals to 1 to r some value and calculate like this, um, and you can take a mid value from L plus r by 2, and you can simply check this m into m is equals to this summation value or not, and if it is equal, then you can simply return this m value. Otherwise you can check this m into m value is greater than sum, then you need to reduce this function. Otherwise you can simply increase the extra space, right. So this will also give you the answer. If we don't find any, then you can return -1. So now its time complexity reduced to O of log n. So from a square root of n, we don't need this, from this to this, right. Now let's check. Yeah, it should also pass. Okay, and integer overflow. Yeah, this should not be L plus r by 2, I think, because this summation is, yeah, this should be r minus r by 2, because it will leads to more complexity, right. So we can also make it half, right. So we can also take it as a 1000, because the constant is only given 1000, so that will be also don't that will not be any problem, there will be no any issue for that. Let's check this. Yeah, it should also pass. Yeah, but I think that previous one approaches don't see these stats. This is only for there are many factors which depends on it. So yeah, so yeah, the complexity will be O of log n and the space complexity will be O of 1 in that case. So I think, yeah, thank you.